Hello everyone and welcome to this lesson. Today we are going to discuss calculus and one of the biggest sections in calculus being cubic functions. So calculus is about 25% of your final paper one that is. And of that, 50% of those marks come from just cubic graphs, and this can be either in the form of sketching or it can be in the form of finding the equation. So today we are going to look at just the sketching portion of cubic functions. By the end of the lesson, we're going to look at how to sketch cubic functions. Very importantly, we're going to look at finding key features such as turning points, points of inflection, and intercepts, and see how that affects the shape of the graph. We're going to use the first derivative a lot. The second derivative, we might touch on that if we get to talk about concavity. And we obviously, very importantly, want to make sure that we label our graphs correctly because that's where we get our marks in the exam. We need to show all of our key points and our intercepts, which we will find as we go through the steps for sketching our cubic function. We also maybe will touch a little bit on calculating the gradients and understanding their significance in cubic functions. All right. Now, there are certain keywords that you will constantly see coming up with cubic functions, and this is whether it's sketching or finding the equation and interpreting the graph. Stationary points, that's another way to say. Turning points, remember that. Intercepts, that's where your graph crosses the axis. It can be either the x-axis or the y-axis. Your point of inflection is a point where the curvature of the graph changes. This is where your second derivative is equal to 0 and your graph becomes either concave up or concave down. It is a section learners get very confused in, and we'll touch on more on that specific part of things when we look at interpreting cubic functions. And lastly, we'll touch on some of the second derivative uses and concavity. All right. Some of the errors that will crop up, especially under time pressure situations in exams, is not reading the question properly and sometimes factorizing functions that are already factorized. And I've got an example to show you where we will touch exactly on this point. We're going to look at incorrect methods that are sometimes used for finding turning points and for getting to equate the derivative to 0. This is all the concepts we will touch on. And look at how to find the turning points by not just focusing on the x, but also remembering to substitute back in to find the function value. And obviously, if we follow through the steps correctly, we should be able to sketch our graph accurately. Importantly, we'll be touching on all of these concepts, but we're focusing really on the key skills in exams that are going to get you to do well in the cubic functions section. Remember, as I said, that's just 50% of your calculus graph section. So we'll look at time management and we'll look at all the critical other skills you need to be successful at cubic function sketching of these graphs. We're going to look at all of that when we get back. Hello everyone, welcome back. Today we are looking at the very important concept of cubic functions and specifically looking at sketching those graphs. All right. So in an exam, it is a big part of the calculus section. So it is one that you've got to spend plenty of time practicing. Some of the problems you may run into when you come across these cubic function questions is not being able to factorize the cubic polynomial, or if it's already in factorized form, sometimes what learners do is they don't realize it's been factorized and then they go through the whole process of factorizing the cubic expression when they don't really need to, and that's a waste of time. So we're going to look at an example on that. Sometimes learners confuse x-intercepts with stationary points. Remember, if you're looking at an intercept, either an x or a y value is going to be 0. Okay, so either the x or the y value will be 0 if it is a stationary point. If it is an x-intercept or a y-intercept. If it is a stationary point that is also an x-intercept, that's only when you will find that your function value will be 0. All right. And remember that we need to allocate time for each step. It's not a process you can rush through. You need to make sure that you've got appropriate time. Sketching of a cubic function can be anywhere from between 12 to about 15 marks in the exam. So you know those questions, sometimes they'll just ask you straight out to sketch the cubic function. You'll know those questions if you've been practicing past papers. Or they might make it multi-step questions in an exam where finding the intercepts is maybe 4 marks and we're spending a mark a minute, so no more than 5 minutes on finding the x-intercepts, for example, of your cubic function. Plotting points and sketching quadratic functions were very important concepts from grade 10 because they teach you how to plot and how to sketch the cubic function. Remember, when we talk about derivatives, there's many uses. We've already seen in a previous lesson where we found gradients and we've looked at equations of tangents, but it also has many important applications in cubic functions. It helps us to find stationary points. It helps us to find maximum or minimum values of graphs. Describing rates of change is a concept that we look at when we discuss optimization. And it also helps us to draw the graph correctly of the cubic function by following the steps for finding the stationary points. So let's have a look at our first question. So here we are asked to sketch the graph of f of x is equal to x cubed minus 4x squared minus 11x plus 30. Now, as I said, there's steps that we need to follow in order to sketch this cubic function. We need our intercepts. We need the y-intercept, which is where the graph cuts the y-axis. How do we find the y-intercept? It's by setting the x value equal to 0. So in our expression, f of x is equal to x cubed minus 4x squared minus 11x plus 30. I replace all my x values with 0. Okay, now when you do this, most of you should already be able to see that we can tell straight away that our answer is going to be 30 because all the terms with x will disappear because their value was 0. So therefore, f of 0 is equal to 30, and that tells me that my y-intercept is 30. So I've already got one of the coordinates that are essential to sketch the cubic function. Okay. The next essential step is to find the x-intercepts. How do we find the x-intercepts? How do we find where the graph cuts the x-axis? Remember, when we're talking about cubic functions, they're generally, not always, but they're generally 3 x-intercepts. The power here telling you how many roots you should have. So they're generally 3 x-intercepts. How do we find them? We have to use the factor theorem, which we learn in grade 11. To factorize, we find what value makes this expression 0. How do we do that? So where is f of x equal to 0? Firstly, guys, before you even look at that, make sure that the equation they gave you is not factorized. As you can see, it's not factorized. If it was factorized, there'd be 3 brackets, or there'll be 1 bracket squared and 1 other bracket. This expression is definitely not factorized, which tells me if I want to find the x-intercepts, I need to use the factor theorem. Now, I've already tested values and I found that f of 2 will give me an answer of 0. But how do you find your factor? You only test values for x. Remember, this is trial and error. You only test values for x that are factors of 30. So, for example, I would not try the number 7 because 7 does not divide into 30. I can try 2, minus 2, 1, negative 1, and any other factor of 35 and 6 and so on. How do we determine that the function value is 0? We simply substitute the x value in place of x. And when you work this out on your calculator, you will see that this value, your function value, would end up being 0. That tells me that f of 2 is equal to 0. Therefore, my factor is x minus 2. Okay, now that we've got a factor, we can find the other factors by using either long division or synthetic division or division by inspection, which is the one that I'm going to show you now. All right, so we've got our expression f of x. We need to factorize that and get our trinomial. You can use division by inspection if you are comfortable with that. There's no, there's no prescribed rule to say what method you need to use to find the x-intercepts. That's really up to you. But I will show you division by inspection because that's the method that I like to use. But really, you use the method that you are most comfortable with. Okay, so to get this second bracket here, I know that my factor was x minus 2. How do I get these terms? To get the first term, we take the x cubed, we divide by the first term in the first bracket. X cubed divided by x is x squared. To get the last term, we take the constant and divide by the constant in your first bracket. Positive 30 divided by minus 2 is negative 15. This is the term that gives learners problems. Okay, how do I find that term? So when I multiply this whole expression out, I need to get these two middle terms, minus 4x squared minus 11x. We choose one of those to work towards. So when I set this up for division by inspection, I've got x minus 2 times x squared, and then we've got minus 15, and then there's some value here that goes in here, so I call it plus kx. Okay, and then I multiply the terms together that will equate to minus 4x squared. So it's minus 2 times x squared and then x times kx. So minus 2x squared plus kx squared must be equal to minus 4x squared. And in that way, I solve for k and I see that the middle term is minus 2. Once you've got that bracket, we can factorize our quadratic. So we've got our factors here of 15, which are 5 and 3. And we need to get a negative 2, so therefore I've got minus 5 and plus 3. So now I've got my x-intercepts. Remember, guys, write these as coordinates because it's going to help you when you sketch your graph. Once you've got these coordinates, you simply have to plot them. So write them as coordinates, okay? You're going to get a mark for each of that. All right. Once you've found your x-intercepts and y-intercepts, we need to move on to finding stationary points. Now, another word for stationary points is turning points. And how do we find turning points in calculus? We have to take the derivative. That's something we discussed right at the beginning. Stationary points, turning points, we find the derivative. So we take the derivative of this function and we solve for x. All right, let's start on this page. See? Take the derivative. So the derivative is going to be 3x squared, deriving that, minus 8x minus 11. I then factorize this quadratic expression. Okay, and we've got to have a negative 8 there in the middle term. So our factors are 3x minus 11 times x plus 1. So therefore I get x is equal to 11 over 3, or x is equal to negative 1. Now, please don't stop there because remember, a turning point is made up of coordinates. All you found are the x values. So we need to find the y values, the function values. So we substitute 11 over 3. You use your calculator, substitute 11 over 3 in here and get your function value. And then we substitute, what was our other one? Minus 1. We substitute those values in and we see what our function value is. All right. You use your calculator. That's calculator work. That's a simple process to find your x and y coordinates of the turning point. Then the last step in the process is to identify the shape of the graph. To help you do that, we look at the coefficient of x cubed and we see whether it's positive or negative. If it is positive, then you have a graph that has first a maximum turning point followed by a minimum. So in other words, it's a positive graph. It starts out sad, but then it ends up happy. Okay? So therefore, when A is positive, you end up happy. If A was negative, then you have a graph that starts off happy but ends up sad. Another word for happy and sad. So we've got minimum, right? And maximum. So it has a minimum turning point followed by a maximum turning point when we have a function where a is less than 0. Now we're in a position to sketch, but do you see how many steps we had to go through? There were 4 steps. We had to find the intercepts, we had to find the stationary points, we then had to find the matching y values for those stationary points, and then we had to look at the shape, and now we sketch the graph, and that's why it's worth so many marks in an exam. Do we have all our key points? Yes. Now we simply just remembering in the back of our head that our graph is going to look like that, okay? We've got our y-intercept. We're going to plot all of our x-intercepts. This does not have to be drawn to scale. You're making a rough sketch. So as long as your coordinates are in the right position, it is fine. It does not have to be drawn to scale. We've plot our turning points. X is minus 1, y is 36. So when x is minus 1, and you can already see my shape is taking form there. When x is minus 1, y is 36. When x is 11 over 3, y is negative 14.18, which is somewhere down there. now that we've got all our points, it's just simply a matter of joining them. We put arrows at the end to show that this continues to infinity. Importantly, you need to, on your graph, mark down all your critical points. So this is -1 and 36. You get marks for this. This point here is 11 over 3 and negative 14,81. So we've got our intercepts shown, we've got our turning points, and we've got full marks. All right, guys. So hopefully these steps, and by following these steps, you will be able to get full marks in the sketching a cubic function question in your exam. Let's take a quick break. We're back after this. Hello everyone, welcome back. Today we are looking at cubic functions, and we're going to continue looking at examples where we're going to put your skills to the test. Remember, there's certain steps you need to follow when you sketch a cubic function, but you can also be asked to sketch cubic functions and interpret cubic functions as well. So we need to know the steps for both of those. Okay. So in this question, we've got a cubic graph that's been sketched, and they've given us the expression. And they've also told us that this expression is equal to -2x minus 5 times x plus 2 squared. Now, I've been hinting at this right from the start of this lesson. I've been saying you need to make note of whether the cubic function they've given you has been factorized or not. In this case, can you see that this cubic expression is equal to -2x minus 5 times x plus 2 squared? That is already in factorized forms. We already have brackets. Sometimes what you might see in an exam is you don't even see this part. Okay? You simply say, you simply get that the graph of g of x is equal to -1 times 2x minus 5 times x plus 2 squared. And from that stage, you already need to recognize that this cubic expression has been factorized. That is extremely important because it reduces the amount of steps and working out that you need to do. Okay, let's focus on our graph now. We've got that A and T are turning points of this graph G, and A and B are x-intercepts. You can see that the turning point is also an x-intercept, hence it's a factor squared. It serves two purposes in this graph. All right. And they also tell you that P is just a point on the graph. All right, let's have a look at what the first question would like us to do. It wants us to determine the length of AB. Now, if you look at AB, remember we've already identified when we read the question that these are x-intercepts. If you're looking for the length AB, we see that this is a horizontal length. To find a horizontal length, we are interested in the x values at this point. And to find this horizontal distance, it's the x value at point B minus the x value at point A. So whatever the furthest coordinate is on your right, it's that value minus the one on the left. Okay, so we need to find the x-intercepts. If at this point you decide, well, let's go and factorize to find x-intercepts, it's going to take you a lot more time. For a 2-mark question, you're going to have spent, maybe 5 minutes because you've needed to do factorizing of that cubic expression. So this is why it's important to pay note of the information they gave you. Remember that this was already given in that form of f of x is equal to, let's just get our factorized expression again. It was -2x minus 5 times by, let's just see here, it was x plus 2 all squared. So we were already given that. Okay, so therefore straight away I can say, well, if f of x is equal to 0, I can see that my x values from the first bracket is going to be x is equal to 5 over 2. So that's the value at point B. And the y value at that point is obviously 0 because we've set the equation to 0. And the other x-intercept is going to come from this bracket. So therefore, x plus 2 is equal to 0. So x is equal to -2. And that's the value at point A. So we've got that this x value is -2. And this one is 5 over 2, which is 2.5. Okay. So to find that length AB is going to be equal to, remember what I said, oops, here we've gone too far there. It's going to be the x value at point B, so it's 5 over 2 minus 2. 2.5 minus times a minus is a plus. 2.5 plus 2 would give me 4.5. So therefore the distance from A to B is 4.5 units. Now the next part asks us to find the x-coordinate of point T. So we look at the graph, we identify that T is actually a turning point. So therefore now we're looking at the stationary points. We already know that this stationary point here has the coordinates -2 and 0. But what is that stationary point there? And this is where we're going to need our equation again. All right, so T is a turning point of the derivative of this graph. And I just need our equation again. So let's just go back and find it. It was minus 2x cubed minus 3x squared plus 12x plus 20. Let's write that down. It was minus 2x cubed minus 3x squared plus 12x plus 20. Minus 3x squared plus 12x plus 20. So this is our expression that we need to find the derivative of in order to find the turning point. So therefore, if we take the derivative, we get minus 6x squared minus 6x plus 12 is equal to 0. When we're looking for our turning points, we set the derivative equal to 0. Let's divide through by negative 6. We get x squared plus x minus 2 is equal to 0. And then we factorize that. X plus 2 into x minus 1 is equal to 0. So therefore, we get what we expected. So we identify that, yes, we have been given this. One of the turning points is -2, so I know that I'm on the right track. These are little key checks that you can do as you go through the exam. We've got x is equal to -2, and that's already been determined. So therefore, that one is fine, and the x is equal to 1. Okay, they only asked us for the x coordinate. They didn't say find the coordinates of the turning point. So therefore, x is equal to 1 is the answer to this question. It is the x value at point T. Okay. All right, guys. Now for the next one, we are asked to determine the equation of the tangent to G at the point P is -3 and 11. Remember, tangent touches the graph at one point where everything about those graphs are the same. They have the same point of contact and they have the same gradient. They want us to work out the equation of this tangent. So therefore, if we think about a tangent, it's a straight line. So it has equation y is equal to mx plus c. I need the gradient and I need the y-intercept in order to determine the equation of the tangent. Now, remember, we need the derivative in order to work out the gradient. We've got that the graph touches the tangent at the point -3. So therefore, I can work out the gradient at the point -3 by substituting -3 in place of x. So we get -6 into, if I'm going to square it at the same time, -3 squared is going to give me 9. -6 times -3 is going to give me +18 plus 12. All right, so what do we end up with here? You can at this point just put it into your calculator and work it out. In fact, you can put this whole expression into your calculator and let's see what our gradient is. All right, so we've got -6, in brackets we've got 9 plus 18 plus 12, and that gives us negative 24. All right. So now that we've got the gradient, what do we still need? We need the value of c, which is our y-intercept. How do we find that? Well, we've got a point that's on the graph. They gave it to us. So therefore, I simply substitute. So y is equal to negative 24x plus c. I substitute the value for y and x in place of their placeholders in my equation. So therefore, I'll get 11 is equal to minus 24 times by negative 3 plus c. And you can work out that your y-intercept is in fact equal to, let's quickly do this on the calculator. We've got, it's going to be 11 minus, because I'm going to take this over to the right-hand side, to the left-hand side, 11 minus 24 times 3, which is negative 61. So therefore c, which is your y-intercept, is negative 61, and your equation becomes y is equal to negative 24x minus 61. All right. Okay, and let's look at this next part of this question, which is determine the x-coordinate of the point of inflection. And this one is interesting because, remember, your point of inflection is where the second derivative is equal to 0. So we already know, and we've already seen, that our first derivative was minus 6x squared minus 6x plus 12. So to find the second derivative, I need to take the derivative of this expression and make that equal to 0, and that will help me to find the x value at the point of inflection. So this will be minus 12x minus 6 is equal to 0. Therefore, solving, minus 12x is equal to 6, and x is equal to negative a half. Okay, so if we go to where's negative a half on the graph, that's where the curvature of the graph is going to change. So the graph is going to change, in this case, from being concave up to being concave down. And of course, you remember that calculus is about 25% of your final paper 1. So we want to look at typical exam type questions that you will get. Remember, cubic function, multi-step process. You need to remember to follow all the given steps, or all the practiced steps, let's say, that practice steps to be able to sketch your cubic function correctly. You need the x-intercepts, y-intercepts, you need the turning points, and you need the shape of the graph to successfully draw the graph. Okay, let's have a look at the first question. So here we've got a function that's given to us, and we are asked to prove that x minus 2 is a factor. Okay, so already this question is layered. We haven't just been told straight away, draw this graph. It's going to be a question that involves multiple layers. They want us to prove that this x minus 2 expression is a factor of f of x. And remember that a factor means that when you substitute x in place of 2 in place of x, your remainder will be 0. So in other words, f of 2, your function value, will be equal to 0. So let's test that and see what happens. F of 2 is going to be 2 times 2 cubed minus 23 times 2 squared plus 80 times 2 minus 84. When you substitute all of this, you don't need to multiply this out. You can literally just go straight to your calculator and work out what that value is. So we've got 2 cubed, so that's going to be 8 minus 23 times 4. Remember, your aim here is to get to an answer of 0, which shows you that this is a factor. Okay, so that means, obviously now, this is actually good that this comes up, because what it means is that we have made some sort of error. And I see the error I've made here is I didn't insert the first term correctly. So if you already have an end goal in mind, you know that you need to go back and double check why your end goal didn't work out. So our end goal here was to get to 0. We didn't. We got to minus 8, and that's because I forgot one of the coefficients of this expression. So our first term, you'll see, is 2 times 8, and I simply put in 8. So our first term here is going to be 16 minus 23 times 4 plus 160 minus 84. And that gives us the answer that we were after. So therefore, we know that since this is equal to 0, we can say that x minus 2 is a factor of f of x. Okay, so it's simply a one-step process. You find f of 2, use your calculator, and then you've answered that question for full marks. Okay, then they say, again, like I was saying, it's a multi-level question. The next part leads on from the first part. They say hence. Generally, when in maths, if they say hence, it means you are more than likely going to use what you've just done. We don't say hence, we don't use that word lightly. Hence means you need the information from before. Hence or otherwise is going to take longer. Hence or otherwise, factorize f of x fully. Fully means that we've got all the x-intercepts. We've factorized completely and all we've got are brackets. We don't have terms there. All right. So we've already figured out that x minus 2 is our factor. We're going to use division by inspection as my preferred method, but you can use synthetic division to work out your second bracket. When you do your division, you end up with your second bracket being 2x squared minus 9x plus 42. We can then factorize that separately to give us 2x minus 7 times x minus 6. So therefore, for this expression to be completely factorized, it would be f of x is equal to x minus 2 times by 2x minus 7 times x minus 6. So therefore, we will now look at this and say, well, what has the question asked me? Do I need to go further? They said hence or otherwise factorize. They didn't say find the x-intercepts, but this is the key step that you need to be able to find the x-intercept. So by the time you've gotten to this point and factorize this expression, then certainly you're on the road to working out the x-intercepts of this graph. All right, but we don't go further than this. We've answered the question and our expression is fully factorized, which is what they asked for. Next, we need to find the coordinates of the turning points of f of x. Remember, finding the turning points is another way, it's keywords, terminology we need to remember. It's another way to say find the derivative. So since f of x is equal to 2x cubed minus 23x squared plus 80x minus 84, its derivative, we use the power rule. 3 times 2 will give me 6. X to the power 2, we subtract 1 from the power there, minus 46x plus 80. Now, when you are looking for the coordinates of your stationary point, you need to set your derivative equal to 0. And we can simplify this a little bit further by dividing through by our common factor of 2. So we get 3x squared minus 23x plus 40. And this we can factorize further into brackets as 3x minus 8 times x minus 5 is equal to 0. So therefore, we get the x values of our stationary points as x is equal to 8 over 3 and x is equal to 5. But now you've got to stop and say, well, am I done? And the answer to that is no, because they wanted a point. All you've got is the x coordinates. We need to find the function values. So now we need to take these values, substitute it back into your expression. So f of 8 over 3 and f of 5. And we need to see what the corresponding function values are. Okay, so let's quickly do that. So I'm substituting in place of x, 8 over 3. And we'll do one at a time so that we don't make careless errors. Plus 80 times 8 over 3 minus 84. Okay, and there's no way you want a chance doing that out manually. There's too much of room for error. So you really want to go to your trusty calculator, and let's just make sure this time I get the entire expression in. There we go. Let's move this guy over there. So we've got 2 into 8 over 3 cubed minus 23 times 8 over 3 plus 80 times 8 over 3. And of course, you can double check my working as well. And minus 84. And we get that answer there. That's a difficult answer to work with, 2,860 over 27. So what you want to do is convert that to a decimal form and get the answer that you need for the corresponding y value of this turning point. Okay, all right. Let's write that down. I have a sneaky feeling that this is supposed to be a different answer. So we're going to double check this working here. You can double check me here, but I know that this answer is not supposed to be 105 and it's simply calculator work. So you double check this answer to see that you get to 3 comma something there, and we're going to go over that just now. All right. And then if you substitute f of 5, again, it's calculator work. And let's go straight to the answers we should get. When you substitute 5 in, your function value should be minus 9. When you substitute 8 over 3, you should get 3 comma 7, which tells me that I've computed in my calculator incorrectly. So just double check that and make sure that those are your critical points for your turning points. Okay, now we've got all the values we need. Our y-intercept, we didn't talk about that. To find our y-intercept, we find f of 0. So when x is 0, we get negative 84. So that's our y-intercept for this graph. Let's plot these points and then join the dots to get our cubic function. So we've got minus 84 here. That's our y-intercept. We've got x-intercepts of 2, 7 over 2, and 6. And what we needed to remember to do as well is remember we have to have in the back of our heads, what is the overall shape of this graph going to look like? So remember the shape of the graph when a is positive, so when a is greater than 0, you're going to have a graph that has first a maximum turning point and then curves down and has a minimum turning point. So we have a maximum turning point followed by a minimum turning point. Okay, so and we can see that our graph is sort of already taking that shape. We just need to complete it, include our key points, and then get our full marks for this question. All right, there we go. All right, and remember the other key points we need to put on here that are not here at the moment is the values of our turning point. So we've got 8 over 3 and 3.7, and this one down here is 5 and negative 9. Okay, guys, so we've covered quite a lot of information just in this question about concavity and about how we can also use the concepts that we learned to sketch graphs to help us with identifying the shape if a graph is given to us already. I think it's time for us to take a quick break. We're back after this. Hello everyone, welcome back. We are continuing our practice questions on cubic functions. Let's have a look at another exam type question. So in this one, we've got the cubic function sketched for us, and we can see that when we read the question, they say the graph of g of x is equal to ax cubed plus bx squared plus cx, which tells us that there's certain missing information on this graph, and we'll see later on if we need to find that missing information. Let's continue reading. It has a y-intercept of 0, which is drawn on the graph. The x-coordinates of the turning points of G are minus 1 and 2, and then those are obviously sketched, put into the sketch for you. You can see all the information that they've given you is in the graph. Now, what I like to do is when we actually draw the graph for you is just to take a second to analyze it and decide for yourself, well, even though I know they haven't asked me to find the value of A, would A be positive or would A be negative? And that's where the shapes of the graphs become very important. Remember when we were talking about the steps for sketching a cubic function, we said that one of the steps involved finding the shape. So if A is greater than 0, we saw that we have a graph with a maximum turning point and then a minimum. And if A is negative, we saw we had a graph with a minimum turning point and then a maximum, right? So you can see if you match now, does this picture match this one? No, it matches this picture. So it means that A, the value of A, if ever they ask us to find it, they may not, but if ever they ask us to find it, we know that A has to be a negative answer. And those are little checks that you need to do for yourself as you go through the exam, because it's just reminding you that if you get an answer that's positive, you need to go back and see if you've made any careless mistakes, because we can see already just from the shape, A has to have a negative value. Let's have a look at the first question. So the first question asks us, for which value of x will g increase? Now, when a function is increasing, what that means is as the x values get bigger, so as the x moves to the right, the y values move up. So the y values increase at the same time. So you analyze your graph, you break it up into sections, and you look for where is x getting bigger and y getting bigger at the same time. Your function values, where are those getting bigger at the same time? So if I look at a point all the points less than -1, okay, and let's see what's happening here. Can you see the graph is actually decreasing? The graph is going down. In other words, say, let's just take I don't know what this value is, but let's just say this value is 10. You can see that this value for y is much less, okay? The y values are going down. Maybe this is like -2. We don't have the values for a, b, and c, so we can't tell what those values are. But you have an idea that you're going from big y values to smaller y values as your x values are increasing. As you move to the right of the graph, your x values get bigger. So therefore, this section of the graph is decreasing, okay? Let's make a little bit of space on our graph. So that section is decreasing. Now let's look between -1 and 2, which are the x values of the turning points. Now do you see, I start off with a small x value, but a small y value, but as the x values increase, the y values also increase. So you can see this y value here, it's going to be positive. It's going to be much bigger than the y value here. So the y values are increasing as x is also increasing. So therefore, this section of the graph from -1 to 2 is where the function is increasing. So for x, let's write that down as a solution. For x less than 2 but bigger than -1, we have a function that's increasing. To finish off our analysis, we look at the last part. For x greater than 2, we see that the y value here is much bigger than the y value down here. So therefore, this part of the graph, the function is decreasing. So our answer, for which values of x will g increase? It's only between the x coordinates of the turning points. In this case, it's between -1 and 2. Okay, now the next one says, write down the x-coordinate of the point of inflection of g. Now remember, when we're talking about points of inflection, let's just focus on that for a second. Obviously, we've got a question to answer, but when we're talking about points of inflection, it's where our curvature is changing. Okay, so let's just say the point of inflection is somewhere there and analyze what it means when we're talking about points of inflection. You get a point of inflection when your graph changes from either concave up to concave down, or where it changes from concave down to concave up. So your curvature is changing. So it's either going to be concave up or concave down, okay? A good way to remember whether the graph is concave up or concave down is to draw tangent lines to the graph. If the tangent lines are below the graph, then your graph is concave up. If the tangent lines are above the graph, that section of your graph is concave down. So we can see that our curvature is sort of changing at this point here. How do we find that value, which is what the question is asking us, just the x-coordinate? Well, that point is midway between the stationary points. So therefore, to find that point, it's -1 plus 2 divided by 2. 2 minus 1 is 1. 1 divided by 2 is a half. So the x-coordinate is x is equal to a half at the point of inflection. That's where your curvature is changing. And if you look at your graph, you can see that that value does make sense for more or less where the position of the point of inflection is on this graph. Okay. For which value of x will the graph be concave down? Again, looking at your points of inflection, at the point when the second derivative is equal to 0, you get your point of inflection. If your second derivative is positive, then you have a graph that's concave up. And if your second derivative is negative, then you have a graph that's concave down. So for which values of x will g be concave down? So remember we had a half, which was sitting somewhere here. Okay. And we're looking at the shape of the graph. You can also use tangent lines to help you work this out. So for this section of the graph, we can see that our graph is concave up on the sketch. And for this section beyond a half, your graph is concave down. So therefore, when x is greater than a half, then your graph is going to be concave down, and when it's less than a half, your graph is concave up. Okay, guys, so we've covered quite a lot of information just in this question about concavity and about how we can also use the concepts that we learned to sketch graphs to help us with identifying the shape if a graph is given to us already. I think it's time for us to take a quick break. We're back after this. Welcome back, guys. So today we've covered a very important section, being sketching of cubic functions, and we looked a little bit on the interpretation of cubic functions as well. Let's see in total where we're up to in our study of calculus, and a reminder really of what the important concepts are in the exam. Calculus is a huge section, 25%. It covers all these topics that you can see. The main one that's important for exams is cubic functions, and so we've spent a bit of time today talking about cubic functions. We looked at sketching a cubic function, and remember the important thing that we learned about sketching, there's many important things. Let me not say the important thing. We saw that it was really important that we follow the steps. So when you sketch a cubic function, there's key steps you need. You need to find the intercepts, you need to find the stationary points, you identify the shape, and then only are you ready to sketch the cubic function. Okay? And let's move on and remind ourselves about some of the key words that we learned, that we already learned, hopefully well before we watched this, was stationary points. That's the point where the graph turns. It's where the first derivative is equal to 0. Your intercept, so that's where the graph crosses the axes. So you get x-intercepts and y-intercepts. A point of inflection is where the curvature of the graph changes. So it either goes from concave up to concave down, or from concave down to concave up. We find the point of inflection by setting the second derivative to 0. The sign of the second derivative tells us whether the graph is either concave up or concave down. The concavity is really just helping you to work out the shape of your function. All right. Some of the things that you need to be aware of, and hopefully that you saw now through our practice session, is to avoid these mistakes. If a function is already factorized, do not try and use the factor theorem all over again, because you're going to just take too much of time. You're going to spend unnecessary steps there. Also, when we look at the turning points, remember to always substitute your x value back in so that you work out your y values as well. Okay, you must find the y values. On your graph, make sure you label all of your points. You need your x-intercepts, your y-intercepts, and your turning points all need to be on the graph. All right. And really, if you follow your steps for sketching your cubic function, so if you look for all your critical points that you need for the graph, also remembering how we spoke about time management. So sometimes these cubic questions, they're broken up into parts. You might have question 1 is worth 4 marks, and then question 3 is worth 5 marks. Let the marks guide you. How do you let marks guide you? You practice many exam papers, and you do the exam, you time yourself so that you can see it's a mark a minute, no more. You obviously need to give yourself those extra minutes at the end to check everything and make sure you haven't made any careless mistakes. So practicing past exams is key, all right? I cannot stress that enough. And to help you to practice past exams, I've got a few questions on screen where you can go and find similar practice questions like we did today on cubic functions, but there's a whole lot more. So don't be restricted to only these. When you've done your prelim and that, you can use your prelims as well as a good indicator of what your final exam will be like. All right, guys, that's it. Thank you for joining me. Cheers.